this demonstration, we will import a DWG file into SOLIDWORKS to create a 3D solid model. The Import dialog box allows us to choose the layers and unit types to use. Next, the entities in the DWG file are automatically imported to a 2D sketch in a new SOLIDWORKS part document. Specially designed tool sets allow us to identify the orthogonal views from the drawing, in this case the front and right views. Next, we align these views relative to each other in 3D space. If desired, we can edit these views to modify our sketch geometry. Let's eliminate the 2D thread profile so we can later create accurate 3D helical threads. Utilizing the Trim Extend functionality, let's extend the rear thread relief angle to the major thread diameter. We will also do this for the front thread relief angle. Adding a line between the two completes the pin blanking profile for our 3D helical threads. Next, we create our initial 3D model, which now contains information such as the mass, volume, surface area, and center of gravity for our part. Now let's select the sketch geometry in our right view that represents our milled flats. By additionally selecting in our front view, we define the start and end location of our flat. According to the imported DWG geometry, the milled flats need to terminate on a 45-degree chamfer. This chamfer can be defined by selecting existing sketch geometry and edges in our front view. Once the geometry is selected, it is trimmed to create a closed boundary. This boundary is then utilized to create an extruded cut feature, which becomes our milled chamfer. Additional capabilities such as feature patterning allow us to quickly copy this milled chamfer to the remaining milled flats on our part. Let's turn off the display of our imported sketch geometry to reduce screen clutter. Now let's create our 3D helical threads. We will begin by drawing a circle that represents our thread depth. A depth of 51 thousandths is appropriate for a 12-pitch V thread. We can use this circle to create the helical definition of our thread that contains the thread pitch as well as the start and end location for our thread. In addition, we can create multi-start, tapered, and variable pitch threads. A library of different thread profiles, such as a 60-degree V thread, can easily be dragged and positioned relative to the start location of our threading cycle. Once this is completed, we can create our 3D helical thread. The resulting solid model is now ready for finite element analysis, detailed drafting, CNC programming, technical publications, and 3D collaboration.